Okay, in the previous class, we have discussed about convolution integral. So we have yt is equal to integration of x tau ht minus tau d tau. Okay, and this convolution, it basically gives you the response of a linear time invariant system to any input xt. So if the system has an impulse response ht, and if you apply input xt, your output yt is given by this equation, this integral, which is called as convolution integral. And since convolution is a commutative property, so you can also write this equation as h tau x of t minus tau d tau. Okay, so whether you use this equation or use this equation, your output will be similar for both the cases. Okay, so we will discuss some problems on this. I take one simple example. Suppose you have two signals. One is xt is equal to e raised to power minus at ut for a greater than 0, and the second is ht is equal to ut, and you have to find the convolution of xt with ht. Okay. Otherwise, this problem can also be stated like this, that if xt is equal to e raised to power minus at ut is applied to a system having impulse response ht, what will be the output of the system? Okay, so you have this equation yt is equal to integration x tau ht minus tau d tau. Okay, in the discrete case, it was yn is equal to summation of xk h of n minus k. So we have seen there that in order to find the convolution of x and h, we have used four operations: folding, then shifting, then multiplication, then addition. Now the procedure is same here, but in place of in place of addition, you have to do integration. Otherwise, folding and shifting and multiplication, they are same. And the major difference between these two is, in this case, you find the output sample by sample. That is, you find for n is equal to 0, then you find for n is equal to 1, n is equal to 2, and so on. Okay, so for n is equal to 0, we just fold one signal, multiply with another, and add, you get y0. For n is equal to 1, we have folded, then shifted by 1 to the right, then multiplied, then add again, you get y1, and so on. Now in this case, since t is continuous, so you cannot find the output in a discrete manner. Okay, because t can take any value. I cannot find it for t is equal to 0, then for t is equal to 0.1, then for 0.2 or 0.002, and so on. So what we do here, we find, since it is integration, so we try to find out the limits of integration within which this product remains constant. So between that time interval, you can find the integration at once. Okay, and how you do it? First, you have to express the function x and h in terms of tau, like we have done here in terms of k. Xk, we have plotted xk, then hk. Okay, so I will first plot xt in terms of tau. So if you plot this function, it is exponential signal, and since it is multiplied with ut, it will be 0 for t less than 0. So you have a function like this, exponential decaying function. This is x of tau. Now in place of t, I am using tau. So at t is equal to 0, its value is 1. The second function you have h of tau, it is simply unit step function like this. So for tau greater than 0, it is 1, otherwise it is 0. Now you have to first generate h of t minus tau. It means first you have to fold this function. If I fold it, I will get h of minus tau. Okay, so if you fold it, it will become like this. It will go from minus infinity to 0. Initially it was extending from 0 to infinity. And then from h of minus tau, I have to generate h of t minus tau. So h of t minus tau, which is basically h of minus tau plus t. So it will be shifted to the right or to the left, this function, depending upon whether t is positive or negative. If t is greater than 0, it is positive, this function h of minus tau will be shifted to the right by t. So it will become like this. H of t minus tau for t greater than 0. And if t is less than 0, in that case it will be shifted to the left by t. This is for t less than 0. H of t minus tau. Okay, so once you have generated h of t minus tau, then you have to multiply it with x of tau. And then you have to integrate. That is how you get yt. Okay. Now when you multiply x of tau with h of t minus tau, and if t is less than 0, in this case, if you multiply these two signals, this and this, you will see that the product is 0. Okay, because this signal x tau is non-zero for t greater than 0, and for t greater than 0, this signal h of t minus tau is 0, and for t less than 0, this function is 0. So as a result, if you multiply these two signals, you are going to get 0 output. Okay, it means for t less than 0, your output yt will be 0, because when you multiply these two functions, there is no overlapping region. So as a result, your product is 0, so integration is also 0. Now what happens when t is greater than 0? When t is greater than 0, you get this function h of t minus tau. And when you multiply this function with x of tau, okay, so what will be my product? If you multiply x of tau with h of t minus tau for t greater than 0, so one function is like this. Okay, another function will be like this. For any value of t which is greater than 0, this can be here, this can be here, also anywhere. So when you multiply the two functions, what you will get? From 0 to t, you are getting non-zero values. Beyond t, again it is 0. Okay, because after t, h of t minus tau drops to 0. So as a result, you are get, this is my region of integration, 0 to t. It means for t greater than 0, what will be my output? My output is nothing but this integration will go from 0 to t x tau h of t minus tau d tau. Okay, so you have to evaluate this integral. Okay, so when you evaluate it, my yt will be 0 to t. Now x tau is what? X tau is this function. It is e raised to power minus a tau. Since ut is 1, I can drop it. And h of t minus tau from 0 to t, h of t minus tau is nothing but unity. So it is simply raised to power minus a tau d tau. Okay. So you just evaluate this integral, you will get output that So if you integrate it, it will be e raised to power minus a tau divided by minus a limits from 0 to t. So it is minus 1 by a upper limit e raised to power minus at minus lower limit. When you put tau is equal to 0, it is 1. So you can take this minus outside, you will get 1 minus e raised to power minus at upon a. So this is the convolution of the two signals for t greater than 0. And for t less than 0, your output is simply 0. Okay, this is how you find the convolution. So you have to find basically the time limits within which this product remains constant. So in this case, I have shifted h of tau, folded, shifted and multiplied with x of tau. Now since this is a commutative property, in place of folding and shifting h of tau, you can keep h of tau as it is, and you can shift and fold x of tau. You are going to get the same answer. Okay, let us see how it will happen. We have got the solution that yt is equal to 1 minus e raised to power minus at upon a. Okay, for t greater than 0, and it is 0 for t less than 0. This is my output. And what was the function? The function was xt is equal to e raised to power minus at ut. The second function is ht is equal to ut. Now suppose in place of folding and shifting ut, if I shift and fold xt, it means I plot again the two functions in terms of tau. This is x tau and this is h tau. This is unit step, this is exponential signal. Suppose I fold it, it means I'm using the second equation, yt is equal to integration of h tau x of t minus tau t tau, the commutative property. Now I am folding and shifting x, not h. Okay, if I fold it first, it will become x of tau minus tau. The function will become like this. And then when I shift it, again either it will be shifted to the left or right depending upon whether my t is positive or negative. So x of t minus tau for t greater than 0, it will be shifted to the right by some time t. And for t less than 0, it will be shifted to the left. This is 1, this is t, this is for t less than 0. Then you have to multiply the two functions. That is, you have to find now h of tau into x of t minus tau. So if t is less than 0, again if you multiply h of tau with x of t minus tau for t less than 0, there is no overlapping region, so your output will be 0. But for t greater than 0, you can see that from 0 to t, so 0 to t, this much area will overlap. Okay, so you have one function like this, the second function is like this. This is ut, this is x of t minus tau. So if you multiply them, you will get this as the common region or overlapping region. Beyond this, it is 0 because xt minus tau beyond t is 0. Okay, so you have to again integrate, you have to find yt. Limits of integration will be again from 0 to t. So t can be any point. If it is here also, this much is my overlapping region. It means I have to again integrate from 0 to t only. Okay, so h of tau, now in this case h of tau is 1 and you have to find x of t minus tau. Now this is xt What will be x of t minus tau? It will be e raised to power minus a. T will become t minus tau and d tau. Okay. So if you solve this integration, you will get e raised to power minus at into e raised to power a tau d tau. And since e raised to power minus at is constant, the integration is with respect to tau. So I can take it outside the integration. So 0 to t e raised to power a tau d tau. So it will become e raised to power minus at. The integration of this is e raised to power a tau divided by a 0 to t. So it will become e raised to power minus at upon a upper limit e raised to power at minus lower limit. And so if you multiply this e raised to power minus at with this, you will get 1 by a e raised to power minus at into e raised to power at. It will become 1 minus e raised to power minus at for t greater than 0. So this solution and the previous solution, they are exactly same. Okay, it means either you can fold and shift xt, or you can fold and shift ht. Your output is going to be the same. Okay, so I will take one more example on this to make it clear. Suppose you take two signals. One is xt is equal to or if I suppose plot it, you have one function xt, and then second function you have ht, and suppose this is 0 to 1, it is 1, and between 0 to 2 this function is 1. You have to find their convolution. Okay, again first you have to represent them in terms of tau, xt and ht both. So I have to write it as tau. So one function is my x of tau, this is tau, 0 to 1 it is 1. The second function is h of tau, 0 to 2 it is 1. Now I have to find the convolution yt integration of h of tau x of t minus tau d tau, or you can take x of tau h of t minus tau d tau, whatever you want. Okay, so in this case I am folding and shifting x tau. Okay, it means I have to keep h tau as fixed. Now I have to fold first x of tau. It will become x of minus tau, 0 to minus 1 it is 1. Then again you have to find out the limits of integration. So first if you shift this, if you plot x of t minus tau now for t less than 0, this function will be shifted to the left by some time t. Okay, that time can be anything. So as a result, if you multiply these two functions, your output is again 0. Okay, it means my yt, it is 0 for t less than 0 simply. Now for t greater than 0 you have to see the time limits within which this product takes the same equation. Okay, now for t greater than 0, what will happen? X of t minus tau for t greater than 0. This function will be shifted to the right by some time t, maybe here. Okay, and then you multiply with h of tau and x of t minus tau, you will see that this much is the overlapping region. Okay, now up to which time this product remains constant? You will, this function can be here, this function may also be here, it may be shifted by this time. So this much is your overlapping region. Initially it was this much, now it will become this much from 0 to t. So t can be anything greater than 0. Now this equation will remain same until and unless this left edge of x of minus tau will reach at 0. At that point will it happen? Now see, you are taking h of tau as fixed. This is 0 to 2. Okay, and your second function, that is x of minus tau, 0 to minus 1. Now I am shifting this function to the right by some time t. So it may be shifted by this much time. Suppose it goes to here to here. Okay, it means your one window is fixed, the other window is basically sliding to the right. Then it may go like this. Okay, so unless and until if this signal x of minus tau is shifted by 1, you will have a situation like this, 0 to 2, this is fixed, and the second function, it will be shifted by 1, it will come like this, 0 to 1. Okay, so you have one limit between 1 to 0 to 1. So 0 to 1, when you shift this signal for any time between 0 to 1, your equation remains the same. So at t is equal to 1, this small box x of minus tau, the left edge of this will reach at t is equal to 0. And for t greater than 0, what will happen? Now since this is fixed, 0 to 2, so at t is equal to 1, this is the situation. For t greater than 1, this will be shifted to right by some time t, and this box will come entirely within this h of tau. Okay, it means this is the common overlapping region, and this will again remain constant till this point will reach here. So at that time, what will be the situation? You will get a situation like this, 0 to 2. It means when this function is shifted by, when x of minus tau is shifted by 2, at that time the second function will reach here between 1 to 2. Okay, and beyond that, if you shift it beyond t is equal to 2, some portion of this will go outside this. Okay, because this is sliding. Now this small box which is fitted inside this h of tau, it will shift beyond the uppermost edge of this function, and you will get only this common overlapping region. And this situation, it means now we have limits of integration from this point to this point only. Beyond this it is 0. Okay, and at t is equal to 3, when you reach at t is equal to 3, you will have a situation like this. Your function h of tau will go from 0 to 2, but the second function will go from 2 to 3. And for t greater than 3, these two functions will be separated. The product will be again 0. Okay, so how many limits you have? You have one limit for t less than 0, it is 0. The second is between 0 and 1. Okay, and third is between 1 and 2. Then the next is between 2 and 3, and then for t greater than 3. So for t greater than 3 it is 0, because these two functions will not overlap, they will be separated. The product is 0. For t less than 0 is the same situation. In between you have to find the values. What is the value of yt between 0 and 1, 1 and 2, 2 and 3. Now if you take this case between 0 and 1, when your t is between 0 and 1, so from 0 to some time t, these two functions, they have some overlapping region. So what is the product? This is 1. You can either integrate, or in this case it is simply a rectangle. So this is 0, this is t, and this height is 1. Okay, so integration of this pulse means the area under this curve. So it is simply 1 into t, that is t. So between 0 to 1 it is t. Okay, now when you reach at t is equal to 1, you will get this situation, and for t is equal to 1 to 2, this box will come inside the another box. This height is 1 and this width is also 1. Okay, because this is the width of this x of minus tau, which is 1. It means this area is 1. Between 1 to 2, this area is unity. At t is equal to 2, you have a situation like this. The rightmost edge of both the functions will coincide. And for t greater than 2, you have this situation. You have only this much overlapping region. It means what is my overlapping region from this point to this point? Since the height is 1, now what is this width? I have shifted this function by t. Now it means my t is here. Okay, t is here and this point is fixed at 2. So what will be this point? The total width of this from this point to this point is 1. So if it is t, this must be t minus 1, this point. Okay, so what is this difference? This is 2. This width will be 2 minus t minus 1. Okay, or it will be 3 minus t. So between 2 to 3, the function is 3 minus t. Okay, so this is what is the convolution. So if you plot it, I will get yt between 0 to 3. Between 0 to 1, it is simply equal to t, that is, it is a linear function. So at t is equal to 1, it reaches at 1. Then it remains constant at 1 between 1 and 2. And between 2 and 3, this function is 3 minus t. It means when you reach at t is equal to 3, it will drop to 0. 3 minus 3 is 0. So it will go like this. Okay, so this is the output or the convolution of xt and ht. Okay, I hope you understand this, and you need more practice on this, because this convolution integral is somehow more complicated as compared to convolution sum for discrete case. Okay, so I will just repeat again this. You have x tau, you have h tau, you have plotted x tau, h tau. I am keeping h tau as fixed. I have folded x of tau to get x of minus tau. Then I am shifting it and multiplying with h tau and integrating them together. So for t less than 0, it is 0 because there is no overlapping region in this product. For t greater than 0, we have one situation that from 0 to some time t, the two functions will overlap. So as a result, the product will be t. Now at t is equal to 1, when you shift this signal by 1, it will reach here. It will come like this. And beyond that, this box will always come inside this larger box. So as a result, this product will remain 1. Okay, and at t is equal to 2, you have this situation. For t greater than 2, the small box will be shifted to the right. As a result, a portion of this will come outside of h tau. So you have only limits from this point to this point, that is t minus 1 to 2. Okay, so you have a problem for this, that you have to find the convolution of xt with ht using this equation. Yt is equal to integration of x tau h of t minus tau d tau. Okay, it means in place of folding and shifting x of tau, you have to fold and shift h of tau. and you have to find the solution. Your answer should be same as this. Okay, this solution you have to submit.